Alright, so measures of center are going to be ways that we can get near the center of a set of data. The main ways that we can get to the center of a set of data are by finding mean or finding the median. Those are both measures of center. The mean or arithmetic mean of a set of data is the measure of center found by adding the data values and dividing by the total number of data values. So usually people call this what? The average. So a mean is an average. Everybody in here, I'm sure, has done that at one time or another. If you haven't, then you probably don't care a lot about number grades, because usually people want to know what their test average is, or homework average, or something like that. Okay, so it's really easy to find the mean, especially if you use a calculator. Some of the important properties of the mean: sample means drawn from the same population tend to vary less than other measures of center. So, you know, if we draw different samples, maybe I wanted to find the average of your test averages, and I randomly chose 3 students, and then I randomly chose 3 other students, and I randomly chose 3 other students. So those means will vary less than other measures of center. The mean of a data set uses every data value. So if you want to find your test average and you have 10 tests, you can't leave one out. A disadvantage of the mean is that just one extreme value or outlier can change the value of the mean substantially. So what does that mean? No pun intended. That means that if you have, say, 10 tests, and you make in the 90s on every test, and then you make a 20 on one test, that can drastically affect your mean. So one outlier can affect the mean. All right, the symbol that we can use for the mean, or how to find the mean, mean is equal to this letter right here. Until you say that's not a letter, that's a symbol. But this letter, this symbol, is a capital sigma. And sigma means to sum up. So the mean is sigma x divided by n, where x is the data items and n is the number of data items. All right, so sigma x means add up all the x values, or add up all the data items. N means divide by that number of data items. Okay, you may also see this x bar. We call this x bar. It's an x with a bar above it. Okay, that's another way of symbolically writing mean. So if I write x bar equals, that's telling you that the mean equals. Also, x bar, you want to associate that with the mean of sample values. So if you see x bar, that is the mean of sample values. Mu, this letter right here, it kind of looks like a U, but it kind of doesn't, because it's got a little extra line here. That is the Greek letter mu. I believe that's a lowercase mu. That is associated with the mean of a population. All right. So if you see a formula that has mu, that's a population mean. If you see a formula that has x bar, that's a sample mean throughout the rest of the book, and it's used over and over and over. All right, so everyone in here, like I said, has calculated a mean of some type at one time or another. They're not hard to do, and I would suggest using a calculator to do so. All right, there's an example in your book here when they're finding the mean of the counts of the different chocolate chips and different cookies. They added up the number of data items, which were 5, so then they divided by 5. So the mean of the first 5 chips was 23.4. All right. The median. Let's see what the median is. If you drive a car, then more than likely at one time or another you have seen a sign that said stay off the median. All right. So what is the median in terms of statistics? The median is the middle value. All right. So if you have the original set of data and you have ordered the data either from least to greatest or greatest to least. So I'm going to write here data must be ordered. Then we can find the median by taking the middle data value. Now, if you have an even number of data items, for example, let's say that I had the data set 1, 2, 3, 4. 4 numbers. There is no middle number, is there? So what you have to do, if you have an even number of data items, is take the two middle, the one to the left and to the right in the middle, add them together, and divide by 2. So the median for this set of data would be 5 over 2, or 2.5. Of course, if you have an odd number of data items, that would be the easiest scenario, because let's say I had this set of data, 1, 2, 3. Then the median would be just the middle data item. So the median here is equal to 2. All right. Important properties of the median. The median does not change by large amounts when we include just a few extreme values. So what does that mean? You have 10 tests and you have them ordered from least to greatest. The median is not going to change just because you made a 20 on one of the tests and you made 90s on all the rest. All right, the outliers do not change the median very much. The median does not use every data value. So you forgot what you made on a couple of test grades that were really high, that's not going to affect the median. All right, here's an example of finding the median. You see 5 data items. You see this middle data item here, that's the median, 23. Remember we found that the mean was 23.4. The median is 23. So you can see they are, they're different, but they're around that same number. Here's an example of having an even number of data items. So if you have 6 data items, then you have to take the 2 middle data items and add them together and divide by 2. So they got the median was 23.5. All right, here's a caution. This just popped up on the screen. Caution. Never use the term average when referring to a measure of center. The word average is often used for the mean, but it is sometimes used for other measures of center. To avoid any confusion, we use the correct and specific term, such as mean or median. Average is not used by statisticians, and it will not be used throughout the remainder of this book when referring to a specific measure of center. All right. Another measure of center is the mode. The mode of a data set is the value that occurs with the greatest frequency. Data value that occurs with the greatest frequency, or the most. That's what that means. All right. A data set can have one mode, more than one mode, or no mode. You don't have to have a mode for a data set. If you have two data items that occur with the same greatest frequency, then each one is a mode, and your set of data is said to be bimodal. That means that like bicycle has two wheels, bimodal means you have two modes. So you would say, well, if you have three, is that trimodal? No, if we have more than two modes, we usually just say it's multimodal. Multimodal. When no data item is repeated, there's no mode. Okay? So you can have one mode, you can have 100 modes if the data set was large enough and the number of frequency was the same for all of those. All right? Or you could have, if none of the items are the same, there's no mode. So let's look at this example real quick. So we have 22 chips, 22 chips, 26 chips, 24 chips, 23 chips. The mode is 22 because 22 occurs with the greatest frequency in that set of data. All right. Here's another example. Here's a set of data here that has two modes. See, we have 22, 22, 22, 23, 23, 23, 24, 24, 26, 27. It has two modes because 22 occurs 3 times and 23 occurs 3 times, and that's the largest frequencies. All right. The next set has no mode, 22, 23, 24, 26, 27. No item is repeated, so that's no mode. All right, now this is important too. In reality, the mode isn't used much with numerical data. However, the mode is the only measure of center that can be used with data at the nominal level of measurement. Remember, the nominal level of measurement applies to data that consists of names, labels, and categories. So like, say I had a list of, are you Democrat, Republican, or Independent? Then I could find the mode of that set of data, and you see it would be kind of useful. Like, there are 15 independents in here, or something like that. And that 15 could be the mode. So it could be useful in data that could be measured only at the nominal level of measurement. All right, the mid-range is another measure of center. All right, the mid-range, it says, of a set of data is the measure of center that is the value midway between the maximum and minimum values in the original set of data. It is found by adding the maximum data value to the minimum data value and then dividing by 2. All right, so you find the biggest data value, you add the smallest data value or the minimum data value, and you divide by 2. That gives you the mid-range. All right. Now, the bad thing about the mid-range is that it is extremely sensitive to outliers. So, you know, we have your 10 test grades, and you make a 20 on one test, and then maybe your highest test grade is a 98. You add those two test grades together and divide by 2, you see that that will be affected greatly by that 20. Okay. The book says the mid-range is merely used, but it has 3 redeeming features. Okay. The mid-range is very easy to compute. The mid-range helps reinforce the very important point that there are several different ways to define a center of a data set. And the value of the mid-range is sometimes used incorrectly for the median. So confusion can be reduced by clearly defining the mid-range along with the median. So I don't really see those as redeeming features, but that's what your book says. Really easy to find the mid-range. Here's an example here. You take the smallest number, 22, the largest number, 26, add those two together, and divide by 2. So the mid-range for this set of data is 24, or 24.0. All right, so we're all interested in how do we need to round our answers. What are the round-off rules? All right, so when calculating the mean, median, and mid-range, carry one more decimal place than is present in the original set of values. For the mode, leave the value as it is without rounding. So what that means is, you see this set of data here that we just looked at for the mid-range? There's no decimal, there's no tenths position. So you think about the decimal like it was maybe after the number itself, add 1 to that. So for this set of data with whole numbers, you want to add a decimal. If you look back, when we're looking over the median, this set of data has no decimal, you add 1 decimal, that's where the 0.5 comes from. And the same thing with the mean. Went over the mean, got 23.4, so no decimal, add 1 decimal place. If your set of data has 1 decimal, then add another decimal. Okay, that's for the mean, the median, and the mid-range. For the mode, we want to just leave it as a whole number. We'll leave it, not as a whole number, but we want to leave it the same as the original data set. So no rounding, just take that item. All right. We can calculate the mean of a frequency distribution. We actually have a formula to calculate the mean of a frequency distribution. I believe there are some homework problems on calculating the mean of a frequency distribution. All right, let's take a look at that. The formula is the summation of frequency times class midpoint then divide by the sum of all the frequencies. Okay. Might want to make yourself a note. That's the class midpoint. And divide by the sum of the frequencies. So you have to figure out all of these values for each class. You have to say the frequency times the class midpoint, the frequency times the class midpoint for all the classes. Then you take the sum of that and then divide by the sum of the frequencies. We'll look at their example real quick. All right. So what your book has already done here, they figured out that the sum of the frequency times the class midpoint for every class was equal to 7201.0. So they went through and, see, this is from table 3.2. They went through and they have the frequency written down. They figured out the class midpoint. Remember how to do that? The class midpoint. And then they made another column. This column wouldn't, of course that column wouldn't be there either, but this column went there. It's the frequency times the class midpoint. They wrote all of those down. They summed them all up and got 2701.0. All right. Then we need the sum of the frequencies. So they come over here and they added all the frequencies together. So we say 2701.0 divided by 78. And then we can get, let's see, 92.3. All right. Let's say we wanted to figure out the mean of this frequency distribution. We have the classes, we have the frequency. We need to figure out the class midpoints All right, we'll do that by just extending this table here. And then we'll make another column that's going to be the frequency times the class midpoint. Then of course we're going to need to find the sum of the frequencies, and we're going to need to find the sum of the frequency times the class midpoint. Okay. So, class midpoints, 20 plus 29 divided by 2, 34.5. Is that how you find it? Or do you find it by taking the sum of two consecutive lower class limits and dividing by 2? Just had a test on this. Alright, so class midpoint's different from class width. So add the two together, divide by 2. So 24.5. I believe you're going to see a pattern emerge. So look at the next one. 30 plus 39 divided by 2. 34.5. So yeah, that's the pattern. Now, this next column here, we get those by saying the frequency times the class midpoint. So these numbers are going to get larger. So 27 times 24.5, 661.5. 34 times 34.5, 1173. 44.5 times 13, 578.5. 54.5 times 2, that's going to be 109. 64.1.4, 64.5, sorry, times 4, 258. And these other you just multiply times 1, so let's copy those two down. Alright, now we want to add all of that together. So plus 74.5 plus 84.5 plus, I'm going back up, 109 plus 578.5 plus 1173 plus 661.5. Alright, so I got 2939. Now sum up all the frequencies. 27 plus 34 plus 13 plus 2 plus 4 plus 1 plus 1. It's 82. So the mean of this frequency distribution is 2939 divided by 82. Alright, I'm going to round to 1 decimal, 35.8. So it's about 35.8.